And everybody, welcome. We got Golda speaking, and we are good to go. So everybody, enjoy. Stage is yours.
All right, thank you guys. And actually, I'm really excited to be following Tracy from Pluto, who was just talking about AIs and fraud and trust, because I'm also going to be talking about AIs, fraud, trust, and those kind of problems. I think it's kind of interesting. I just actually was conference hopping. I was here at East Denver, and I went to 2 AI conferences and back to East Denver. And yesterday in San Francisco, it's like everybody's like, "Oh, AI is everything. Everything in the world is going to be AI. It's going to be so great." And it was like so much hype. And it's actually very refreshing to come back here and also get the anchoring, pardon my pun, to identity and who actually is talking and what is true, what is not. So AI actually causes, as Tracy was saying, a greater need for trust systems because it's so much easier. Let me go back here. It's risk. I used to do risk work for Postmates. So I was actually fighting credit card fraudsters at scale. And when you think of fraud, it's not always just like Joe saying stupid stuff on the internet that's misinformation using something. It may be a very organized crime ring that's actually doing fraud for profit. And when you're fighting risk rings, you're actually fighting another team of fraudsters that's attacking your system, and it's kind of that spy versus spy thing. And so there's various types of risk and fraud that you can think of. Some of them that we would run into is account takeovers, where maybe there's a guy's account that was a good account, but then someone got the password or private key. They do a lot of massive, laundering. So all those stolen credit cards, they don't just get used by the guy who got them. They sell them, they bulk transfer them, and then there are people who, launder them at scale. Phishing attacks. Social hacks is actually a big one. We used to always tell all of the drivers, we never ask for your password. And then, of course, somebody calls them and it's like, "Oh, we're Postmates. Can we have your password?" And they were like, "Yes." So social hacking is actually a big thing. That's how actually a lot of chains have been compromised. And, of course, ransomware. So you really have these kind of high-stakes games that are being played. So it's not just a matter of, is this a human? But, there's actually attackers that are systematically trying to subvert whatever system you might make. And generative AI makes detecting fraud harder because LLMs can simulate human behavior much better than anything we've seen before. So telling whether something is a human based on its behavior, based on its timing, based on its click patterns, all those things that we normally were able to do, a lot of those are not going to work. So really, I'm seeing that we're going to need to transition to more trusted and gated spaces for a lot of us. And that's kind of what we were saying as far as, do I want to interact with all the bots? Do I want to interact with all the noise? So there's a lot of opt-in spaces nowadays. There's allow lists. Your mail is probably being sorted to people that you have previously talked to. My phone is blocked unless I have people in my contacts. Essentially, we're creating ourselves little walled gardens that are safer spaces for ourselves. And it's interesting, coming at it from a biology perspective, there's a reason that cell walls evolved. Inside a trusted space, you can be much more open. And it's actually more efficient. And I can tell you this from, looking at what is the bottlenecks on, for example, an IPFS. If you're reading all the traffic from IPFS, the bottleneck is going to be the signature validation. So signature validation, all of those types of validations are expensive, even without going to the blockchain, even without paying the gas. Blockchain is expensive to use. Signature validations are expensive. If you have a trusted space in which you don't have to validate, you can go and scale much more. I mean, we would even not use HTTPS on the internal networks because you want to speed things up as fast as you can once you're getting to massive scale. You don't want to have to validate every packet. So how do you create trusted spaces, supposing that you want to? You need really 2 things. You need long-term identifiers, and you have to be able to share data about the behavior of those identifiers. I think a lot of people here are probably familiar with the prisoner's dilemma, and what that is it's simply, it's a game theory that if there's a repeated game, they're going to behave better. You know, the classic example is splitting the check in a restaurant. If you know the people, you're going to split it more fairly than if it's like a one-time thing and you're never going to see them again. And if it's anonymous, of course, you're going to possibly behave worse. So if there's long-term identifiers, it creates the potential for accountability, the potential for consequences for behavior. So how do you get long-term identifiers in this world where an LLM could like pretend to be anybody at any moment? And then how do you gather the information about them? One of the big things actually from working at Postmates when I was doing risk and fraud is I would do all this work and identify some kind of identifier. We called them assets that were hard to necessarily replace. So it might have been a device ID. It wasn't really a DID with a signature. It was just a device ID. But these things still would have reputations in our system. And if they had a bad reputation, we wouldn't let them in. Now, I might find a device ID being used by hackers, like 5,000 logins just got associated with this device ID. But I would not tell the people at Lyft. And the same guy is probably also laundering credit cards through Lyft and laundering them through Uber and laundering them through every other place that takes credit cards. I mean, what they do is, I'll just tell you a funny story. They would actually advertise Postmates pizza on WeChat, and Postmates didn't sell on WeChat. But if you ordered pizza on WeChat, they would actually fulfill the order by taking a stolen credit card, making an order at Postmates. The guy gets his pizza, but he would pay the WeChat dudes. So it was this, you know, they could do massive fraud at scale with pizza because it's being orchestrated. So these are the, oh, yeah, let me keep this going. Let me make sure, okay. So anyway, I would like to be able to share this behavior, and that's one of the things I'm going to propose here, is that ability to have long-term identifiers as kind of a cultural expectation, and then a way to share that data in data pools. That's the two things I want, just two things. So here's a DID. If you haven't seen a DID before, this is a DID. DIDs are nice because they're a standard. They have private keys that can rotate depending on the DID methods. If you like lose your keys, you might be able to have a rotation method where you could restore your keys. And they're standard across different things. So like Blue Sky uses DIDs. Every message on Blue Sky is signed with a DID. Nostr uses DIDs. Every message on Nostr is signed with a DID. Ceramic uses DIDs. Every message on Ceramic, or Orbis, which is built on Ceramic, uses DIDs. And those are completely separate protocols, but they're all signed with DIDs. And DID is the thing like in your MetaMask wallet, when you sign something, you're signing with your DID, your decentralized identifier. So they can be protocol cross-chain because there's a DID method that's actually a W33 standard. So that provides a powerful identifier that can cross all these different things. And one of the reasons you want to cross things is if you have graph information, if you have cross-domain information, you can protect against fraud better because you have more knowledge about the guy. When a guy just shows up, you don't know anything about him. You have no idea if he's a fraudster or not. But if you see him in a little ring with other fraudsters, probably he is, if he's connected to them. So if he shares like an IP with them, he probably is. If he shares a device ID with them. So you want to have this cross-domain information, though you also want to preserve privacy. So I just want to also give a shout out to separation of concerns, old-fashioned programming stuff. Okay, please. So signal and models are two separate things. The fact that I sign a message doesn't make it true. The fact that I sign a message, this guy's a human, doesn't make him human. Maybe I got fooled. It's just a piece of signal. So the way we would do it, old on Web 2, is you have a Kafka stream, ton of events coming at you, boom, boom, boom. You process them, you store the significant ones in a database, and then you roll up features and you feed them to models. And believe me, I used to be a proponent of heuristics and rules. Models are smarter. I'm sorry. At scale, models can catch the fraudsters better than my rules, no matter how hard I tried to like guess at the best rules. So if you have a source of truth for the model where you can tell it, hey, I found out this was fraud. And we used to do that by allowing some of the stuff to go to chargeback, and the fraudsters would win a little bit. But then we would find them. So if you have a model, it can roll up all these signals and make a prediction. And then if you have a source of truth, of knowing when those predictions are true, you train the model. And the model then is trying to outwit the fraudsters as they constantly change their behavior. So I think from an engineering standpoint, it's better to separate these ideas of a signed thing or a thing that's on blockchain or even a thing that you proved with ZK Trust or whatever. It's just a signal. And it may be a strong signal, it may be a weak signal, but it's not an absolute. It's a signal that goes into the model as a feature, and then the model makes a prediction. Fraud, not fraud. And then you have maybe in some percentage of cases, you have some humans looking at it, you have bad outcomes, depending what outcome you're concerned about. You'll know if it was a credit card fraud because it'll be a chargeback 2 months later. So anyway, you want to have signals, you want to have models that read the signals and make predictions. So yeah, Web3, now comes the ceramic part. I'm going to put my ceramic hat on. I work for ceramic. I like ceramic for this because it is composable. It's all about composable data. It's very low cost. It's cheaper than an L2. We have basically schemas that you can register. Other people can consume them. It's just like MongoDB, except that it's on like, well, right now it's on IPFS, but if you run a ceramic node, it'll actually become a little better than IPFS soon. And they talk to each other. They share the data on streams that you can publish to and consume. And they're cheaper than an L2, but they are anchored to Ethereum. So the idea is that it's very scalable. So a lot of people can publish and consume on ComposeDB at scale. And the hashes are being anchored to Ethereum, but the whole thing isn't being published to Ethereum because that'd be really expensive. So I want to do a live demo, and I figured there would be no good Wi-Fi here, so I did it locally. We'll see if it works. And this is just a really hokey demo, but it's like, I would like there to be a culture that every entity should sign with a DID. Now, normally, of course, it's not going to explicitly like talk to you and sign with a DID. It's going to be something you would call or you would use some code to do. But I just made a fun demo. I'm running NeoGPT here. And I'll just show you that it is live, if it ever runs. And so this is like a really stupid model. It only has 250 million parameters. So somebody give me something, or I'll say, hey, I'm Tracy from Pluto. And let's see. OK, so NeoGPT is thinking, and he says, here to give you more information about the command config. He's just making shit up because this is a really dumb model. But I'm going to ask it, who are you? Ooh, and my little wrapper answered, because I programmed it to, that if you ask it, who are you, now it signs a message with a DID. Now, obviously, you're not normally going to talk to a model and be like, who are you? Let me see your DID. But if you did that programmatically or directly, I think there should be a cultural expectation that everybody everywhere should have a DID that's going to talk to me on the internet if I don't already, if it's not over some kind of secure channel that I already know. Because also, you can't really tell AIs from people unless you make every human get KYC'd. And I don't want to make every human get KYC'd, so I have no idea if I'm talking to a human or a model. But I just want the damn thing to have a DID so I can talk about it. So for example, going back to the demo, I did this earlier, and I did the same thing, and I made it give me the DID. And then I put the DID into, this is a company I sometimes see, but you could program lots of different places that would do this. But this is a group that's doing decentralized trust and linked claims. And then I'm going to tell this interface, hey, this DID doesn't make any sense. It's probably not Tracy, really. It says it is, but it's not. And so then I'm going to sign that attestation with my MetaMask, and I'm just going to say something about it. And I can do that whether this bot gave me permission to or not, because it has a DID, so I can say stuff about the DID. And then the stuff I say can get published on the Ceramic network, and then other people can see it. Like Surscan is not my thing. I don't run Surscan. But as soon as I said something about this DID, it shows up on Surscan because it's part of the Ceramic network, and now other people could consume that data, and they can run their models. So all the signal can go out on the network, and we're using the Ceramic network as an example because it's nice and scalable, but you could do it other ways. I can consume it and make a model over it. You can consume it, make a model over it. If you don't like my predictions, make your predictions, use your anchors of truth. But if we could share this data, then we can all be more powerful against the spammers. And this is an example of that little guy, Link Trust. He makes because he doesn't have enough data right now, those guys don't have enough data to build models. They're just showing you a graph of like who said what about who that you could explore. So that might also be useful. But the main thing is to share the data, and then I can decide which people's data I'm going to consume. Like, I only trust these guys. I'm only going to consume their data. I'm not going to trust those guys. I don't know them. And then it still is a game of spy versus spy, but the good guys, if you ever played Avalon, the good guys are the ones who don't have to lie. If you play the very naive version of Avalon, the guys who can tell each other the truth and be open, those are the good guys, can win. So I'm actually ending kind of early. I'm going to give some chance for questions. But here's some places you can look at more stuff. Shared data at scale. We have the stuff ComposeDB, where you can like make a model, make any schema you want, publish it, consume it, make an app. And then totally separately, not related to Ceramic, is like if you want to play with AI, go get some models from Hugging Face, Mistral, and you can start playing with the AI models, which is just like they're doing more and more stuff faster and faster. So yeah, I want to take a few minutes for questions. I don't know if anybody has any questions. That's about scale. Okay. All right. Well, if you're interested in anything about... Oh, wait, there's a question. Oh, good. I like questions. Questions are good.
Hi. So everything you talked about is underpinned by using DIDs and using DIDs very pervasively. But the amount of stuff in the world is so huge. Isn't there a risk of DID explosion? And at that scale, what does a DID mean if there are billions, if not trillions, of DIDs being generated all the time?
Okay. I'm not sure I heard everything you said, but you said basically will DIDs scale, and like what does a DID mean at scale? Is that?
Yeah, I mean, an explosion of DIDs could be a problem.
Yeah, I mean, obviously, yeah, you do have scalability problems. It depends on what, state you're in. I think the DIDs are really the core thing. I mean, we were able to store data about millions of card fingerprints, millions of devices, millions of logins, without any problem, just like in Postgres, and it fits very nicely into a model. I think DIDs, there's less of them than there are messages, because like there's 9 billion people, and then maybe another 9 billion AIs, and maybe another 9 billion other things. But it's on the scale of countable billions of DIDs, which a model can handle that. A big model can. So yeah, somebody has to be consuming and then rolling up that data. And yeah, that person who's rolling it up is going to have some resources and probably charge for their model's predictions at some point. Maybe they'll give some freemium or something. But yeah, actually rolling up the billions and billions of DIDs and the data is going to be expensive. Somebody has to do that and be funded to do that. But just the fact that they're being transmitted, you don't have to store all of them. They're going to be flying by. They're just kind of like traffic that's flying by. So everybody's not necessarily keeping all of them all the time. But yeah, somebody has to. In order to do effective risk, you have to aggregate a lot of data.
Question. The ceramic model that you mentioned, are there any use cases in the world right now that is gaining traction on?
Wait, I'm sorry, can you say that one more time? I definitely want to hear that.
Are there actually use cases where this model that you described is gaining traction on? I'd like to learn more about the real life use cases.
What are the real world use cases right now for ceramic models?
Correct.
Yeah. So like Orbis is using them. So Orbis has a social network on top of ceramic models. There's, yeah, thank you for that question, and thank you for the other one. There's some decentralized science use cases where they're sharing scientific data. I'd like to see people actually sharing the parameters from federated models. I don't think people are doing that yet, but like for predictive models, you can actually do federated predictions and just share the parameters. Somebody should do that. Of people who are actually doing stuff, Gitcoin is the biggest example right now. If you go on Open Collective and you get Gitcoin passport stamps, if you've ever done that, like validate your Twitter account, that's all on ComposeDB, that's all on Ceramic. Then there's Oamo is doing some stuff. I should know this because I actually measure these guys. Oh, I guess my time is just about up. Gosh, I shouldn't leave people out. But there are a number of people doing stuff from decentralized science to social pact. So there's a number of people. There are reputation cases and other kinds of things in social networks. And game points. Yeah. All right. Oh, my time's up.